what?
Hyperbolas. 11.3.
Yes.
Alright, so let's make sure we really kind of get down the basics. So I can just do one example for you and you'll be good. So let's get the main part down. X squared over a squared minus y squared over b squared equals 1.
Front pocket.
The same rules apply. Has to be equal to 1. And your numerator coefficients have to be positive ones as well. Okay, so that's the basics that you already know. You have a squared and b squared. So here's the issue. Whatever is first is the major axis. So if x squared is first, that's your major axis. It means it's going to be horizontal. If y squared is first, then it'll be vertical. But a and b do not move. So what we're really saying is the positive squared term is going to be first. And the other one will have a minus with it. Okay? So do not move. So it doesn't matter if b squared is bigger than a squared. It's still going to be in that position. Okay? So a little different than ellipses and parabolas. Okay? Okay, what else? Oh, some things you got to list. You still got to find A, B, and C. So let's start with vertices. What do you know about vertices from the other lessons? What's your vertex on your major axis? What letter? A, right? All right. So let's start to draw this. So leave a little space here. We're going to add to it. So we'll call this A. And that's negative A. That's our. Those are our vertices. We're horizontal because X is first. Next thing, we have this thing called transverse axis. And that is nothing more than the length of major axis. 2A. That look familiar? Transverse axis is the length of your major axis. 2A. And the last thing, foci. Oh, not the last thing, I'm sorry. What do you know about foci? What do you remember? It's on the major axis and it's C. So in this case, it's going to be plus or minus C0. Here, your focal points are beyond your vertices. So that's C and that's negative C. And we're going to talk about asymptotes here in a minute. Okay?
Thank you.
Yep. Okay, so let's take a look at this. If you remember from Algebra 2, your hyperbolas had two asymptotes. So before I get to that, what is B? What did we learn B was in the ellipses? In the opposite axis, and that gave us our minor vertices. Okay, so if we say this is B here, put B there and B here, negative B. In Algebra 2, you should have drawn a nice little box. Who remembers drawing the box?
Yes.
Okay, what was the purpose of drawing a box? The asymptotes. Asymptotes go through the center and also through your corners. So this told you how fat or skinny your hyperbolas were. Okay, so then this is your picture, but we're going to take some things from the picture. Teach you a few things here. Okay. Alright, so let's talk about asymptotes. So your asymptotes are straight lines. So they have a slope and an intercept, and the intercept's always going to be at 0, so you don't have that second part to it. But slope is rise over run. So this is a horizontal hyperbola. So it's b over a. We rise b and we run a. So that's how we get that that line. And then the negative b, you rise a negative b, you go down b, and then still to the right. And that's how you get this one. So that's a horizontal hyperbola. So a vertical hyperbola, just real quickly, if it's like this, these are your vertices, so that's A. Let's say B is right here. Just quickly look at this. If that's B and this is A, we're really rising A and running B. So a vertical equation, vertical hyperbola equation for asymptotes is going to be y equals plus or minus A over B x. Because you're rising the A and you're running B. Okay, so somehow make sure you get those right. Alright? Now let's explain how we find A, B, and C, which is very typical. In ellipses, it was b squared plus c squared equals a squared. A was the hypotenuse. In this case, this is a right triangle. This is A, the leg is A and B, which is what we're typically used to. A squared plus b squared. This is going to be C, which C is the same distance for your focal points. So if we take this and laid it down, we would get to that point. So in hyperbolas, it is the typical Pythagorean theorem that you're going to use. A squared plus b squared equals c squared. So yes, there is some places with ellipses and hyperbolas where you're going to make, it gets kind of blurred. You got to make sure you know the difference of what you're using. Okay? So you can put this stuff on your reference sheet. Don't take up a lot of room. A lot of the stuff you kind of already know how to do. Okay, so that's a hyperbola, and that's where it all comes from. What do you have to do? One, you got to make sure that you're in the right form. Okay? Two, you're going to find A, B, and C. And then three, because you have A, B, and C, you can find the vertices, the focal points, and the asymptotes. So let's do a problem. I'm going to pick a kind of a, I'll just pick a different type of problem here. Let's do number 14. 9x squared minus 4y squared equals 36. So we're going to work through this, get all the things we need. What's the first thing we got to do? Yep, need it to be equal to 1. So we're going to divide everything by 36. Alright, and what does that give us?
1/4 over 1/9. Yeah, over 9. Yeah.
Alright, now it's in the correct form. So we need to find A, B, and C. Where is A located? Always. Yeah, it's in the positive squared term. Always make sure your positive squared term is first. So some of these you're going to have y squared minus x squared. That will be a vertical. Alright, so A squared is 4, so A must be 2. B squared is 9, so B is 3. How do I find C? A squared plus B squared, but you got to take the square root, because that gives you C squared. So 4 plus 9, oops, square root of 13. Yay, radicals. Okay. Alright, so you put it in the correct form, you find A, B, and C. Now you need to do this. Tell me the vertices, your major vertices, what are those? And how do you know? Horizontal, right?
Yeah, plus 2, 0, and minus 2.
Yeah, plus minus 2, 0. Alright, how about the focal points?
Plus or minus, or 13, 0.
Yeah, it's plus or minus c. And they're still on the major axis, so they go in the x position. Excellent, excellent, excellent. Okay, now let's talk about asymptotes. Horizontal, so which is which? Which one do we use?
B over A.
B over A. And so that's y equals plus or minus b is 3 over 2 x. So those are your asymptotes. And graphing it should be easy at this point. But you still have to graph everything. Let's write this over here. Vertices at plus or minus 2, 0. B is what? 3? Notice that B is bigger than A. That just means you're going to have a real fat hyperbola. So draw your rectangle and then draw your asymptotes. And then you can draw your hyperbola. But there's one more thing you gotta have.
Your foci.
Huh? Yeah, you gotta put your foci in. So what is the square root of 13 on your calculators?
4 points.
3 point something?
4. No? Yeah, 3 points.
Yeah, 4 squared is 16, so it has to be less than 4.
3.605.
Is it really? 3.6? So there's 2, 3, so just barely past 3. There's your focal points. Pretty good. That's what you need. Get your equation in the standard form. Find A, B, and C. They will be your vertex, your focal points, your asymptotes. Draw the picture. Good. And tomorrow we'll do the other half of this. We'll break this into 2 pieces. So this will be page 748. 5 to 19 odds. Good.